Before we start the renewable sources, we will talk about one more physics concept. Have you heard about something called as AC current and DC current? AC current and DC current, yes. Alternating current and direct current. So if you understand the difference between these two, it will be easier to understand the rest of the topics. You can make a small tabular column. Alternating current, direct current. First, under alternating current, you can write produced by rotating components. Alternating current is produced by rotating components. Alternating current is generally produced by rotating components. Then direct current is produced by static components. Direct current produced by static components. Right. Then example for alternating current. You have seen generators. How a generator runs? It starts rotating. It starts rotating, it produces electricity. So that produces alternating current. You can write example generators. For alternating current, example generators. For direct current, example batteries. Cells or batteries are examples for components that produce DC or direct current. Okay. Then again, under alternating current, you can write the direction of the current. The direction of the current. The direction of the current constantly changes. Direction of the current constantly changes. That is, you take this, the alternating current will be like this. So it constantly changes the direction. Then for DC, you can write the current is unidirectional. The current is unidirectional. It is not fluctuating. Once it starts moving in a particular direction, it always moves in the same direction. So it is unidirectional. An alternating current, you can write easy to produce and transmit over long distances. Alternating current is easy to produce and transmit over long distances. Alternating current is easy to be produced and to transmit over long distances. Then for direct current, you can write it's suitable for storage. DC or direct current is suitable for storage. So that's why we have written DC example, batteries, but for alternating current, mostly generators. Then here, the current that we use, the frequency will be around 50 to 60 hertz. Frequency is number of vibrations per second. The current that we are using, it vibrates up to 50 to 60 times in a second. Frequency is 50 to 60 hertz. But here the frequency is 0 hertz for a DC because it moves in a constant direction. You don't have frequency concept here. Frequency is 0 hertz. Noted? Yeah. So you can close the tabular column. Then where do we use AC? Usually in the like you said, the households, we usually use AC current. That's why when you buy appliance, no, it is written plug to AC power source, because AC means alternating current. The plug or the plug point sockets that you see here, those are alternating current sources. Now you have a UPS. The UPS has a battery also. Let's say we have a battery. Generally above the battery, have you seen there will be one more component? What is this component? Above the battery packs, no? Have you seen there is one thing that looks like a stabilizer? So that's an inverter and rectifier. What the inverter and rectifier will do is, when you have power supply, it's AC current, correct? AC current will be converted into DC current and then it will be stored in the battery. So this is performed by something called as rectifier. Rectifier is something that converts AC current into DC current. Similar to that, when the power goes off, the DC current will be converted into AC current so that your appliances can run. This is performed by something called as inverter. So the box that you see on the top of the UPS, it's inverter rectifier. When the power is there, it will act as a rectifier. When the power is not there, it will act as an inverter. Clear? So you can write inverter and rectifier. Alternatively converts AC into DC respectively. Noted this. Can you go to the next one? So based on this, first renewable energy source that we are going to discuss about is hydroelectricity. Put the title as hydroelectricity or hydro power plants. Hydroelectricity or hydro power plants. So in this hydroelectricity, we usually build a dam, correct? When the water is moving, we call it as kinetic energy. Kinetic energy means energy possessed by a moving object. Then you're going to build a dam like this, and then you're going to stop the water. When you stop the water, what happens? Kinetic energy is converted into potential energy. Potential energy is the energy because of storage or because of configuration. So initially the river was moving. Now you have stored it in form of potential energy. Again, when you open the sluice gates, what happens? It starts moving. When it starts moving, again it's converted into kinetic energy. This kinetic energy is used for spinning a turbine, which means it's converted into mechanical. This turbine is attached to a generator. Generator means it will produce AC current or DC current. AC current. That's how hydroelectric power station works. So you stop the water. When you open the water, it is converted into kinetic energy. Kinetic energy is converted into mechanical energy, and then mechanical energy is converted into electrical energy by a generator. Clear? This is how hydroelectric power station works. Based on this, tell me the advantages and disadvantages of hydroelectric power station. Quickly tabulate. What are the advantages and what are the disadvantages? So first advantage, you can write nil emission. We are not burning anything here, no fission, no incineration, nothing. So first advantage is nil emission or no emission. First is nil emission. Second advantage is flood regulation. Whenever the rain is intense, we can regulate the flood using dams. Flood regulation. First is nil emission, second is flood regulation. The third advantage is less maintenance cost. Even though dams looks huge, the maintenance cost is relatively lesser. Mostly civil engineering based maintenances and then few electrical components. So lesser maintenance cost. Next advantage is multi-purpose projects. Most of these are multi-purpose projects. When we say multi-purpose projects, so when you're building a dam, the dam can be used for regulating flood, for providing drinking water supply, for supplying water for agriculture. Yes, and you can develop tourism, you can develop fisheries. All these are the advantages. Coming to disadvantages, what are the probable disadvantages of hydroelectric power station? First disadvantage is initial setup cost, high initial setup cost. First is high initial setup cost. Second disadvantages, what are the other disadvantages? It can alter the pattern of the rivers, or it can alter the meandering pattern of the rivers. Can alter the meandering pattern of the rivers. Then followed by that, the next problem is, have you heard about RISA? Reservoir induced seismic activity. It is when you build dams, the gravity dams, they can put a lot of pressure on the earth plates, and that can lead to earthquakes also. So what we call as anthropogenic earthquakes or man-made earthquakes. Dams can lead to reservoir-induced seismic activity. Okay. Any other disadvantages? Area, yes. Destruction of natural resources. Since it occupies a large area, it can lead to destruction of natural resources. Also, dislocation of indigenous population or dislocation of local population. Dislocation of indigenous population or dislocation of local population. Okay. Any other disadvantages? Destruction of forest land, meandering pattern will be affected, earthquakes can happen. This is sufficient. If you think or if something comes to your mind, you can add it. Clear? This is about hydroelectric power station. Next, we are going to talk about biomass energy. So what does it mean by biomass? Anything that's produced by a biological component. It can be plant, animal waste, all these falls under biomass. So biomass energy, it covers a wider thing. Even if you burn a wood, that falls under biomass. Burning a coal falls under biomass. Or burning a stubble, agricultural stubble, all these falls under biomass. Three important methods. First is incineration. What does mean by incineration? Burning something is called as incineration. And then you have pyrolysis. What does it mean by pyrolysis? Heating without oxygen. And then anaerobic respiration. These are the three common methods by which we extract energy from biomass. The reason I mentioned these three is, moving from top to bottom, the cost increases. That is, this is the cheapest method and this is the costliest method. But even though the cost increases, this is least polluting, this is highly polluting. Because when you burn something, what happens? Unfiltered. When you burn firewood, a lot of carbon monoxide and other gases will be emitted. But anaerobic respiration is relatively lesser. Have you heard about the gobar gas tanks? Especially in regions like Kerala, no? They will have a gas tank in the backyard. All the kitchen waste or food waste or even the human waste, it is sent to a tank, correct? And inside the tank, we have anaerobic digestion that takes place inside. When we say anaerobic, without oxygen. So this produces a lot of methane, which can be used for heating purposes. So you can burn a stove, you can boil water and everything. All these falls under anaerobic. So these are types of biomass energy. Coming to the advantages and disadvantages. What are the advantages of biomass energy? First is easy raw material availability. First is raw material availability. First is raw material availability. The next advantage is solid waste management. Next advantage is solid waste management. How do we say solid waste management? If you see markets, a lot of rotten vegetables, rotten fruits, broken grains will be there. No? They will usually throw it. Sometimes the cattle will feed on it, and also it can lead to a bad smell, and it can also spread diseases. But when we build anaerobic respiration gas tanks, usually there are many markets in Andhra and many regions where they collect all the rotten vegetables and fruits, they put it inside a gasifier, undergoes anaerobic respiration, and then they produce electricity based on that. So, and then it can turn into manure also. All the leftover products, it can return to the farmlands, it can be used as manure. So the next advantage is the byproducts can be used as manure. The byproducts can be used as manure. Byproducts can be used as manure. Okay, coming to the disadvantages, what are the disadvantages of biomass energy? First disadvantage is longer production time, because you cannot instantly convert biomass into anaerobic respiration. Production time is higher. First disadvantage is production time is higher. Second disadvantage is initial setup cost. Even that provides a decentralized power production, the initial setup cost is going to be higher. Not all the households will be able to afford it. Initial setup cost is higher. Then, any other disadvantage of biomass? Greenhouse gas emission. It is not emitting carbon dioxide. It's not emitting particulate matter, but still greenhouse gases, correct? Methane, carbon monoxide, all these can be emitted. So it can lead to greenhouse gas emission, GHG emission, can lead to greenhouse gas emission. Can lead to greenhouse gas emission. Noted this. Yes. We have completed till biomass. Next is wind energy. Next is wind energy. So how windmill works? How many blades will be there in windmill? 3 blades. Usually the windmill has 3 blades, and then it starts rotating. When it rotates, it's called as mechanical energy, correct? When the windmill rotates, it's called as the mechanical energy. And this mechanical energy in turn is connected to a generator. Generator will produce electrical energy, which means this also produces what type of current? AC current or alternating current, clear? So wind flows, it's kinetic energy. It starts to spin the blade, which is mechanical energy, that is attached to a generator which produces electrical energy. Based on this, what are the advantages of wind energy? Can someone tell the advantages? So first, yes, cost efficient. Yes, we will talk about the initial cost. Cost efficient, true, but initial cost is higher. So the first advantage is nil emission. Nil emission. Nothing is being burnt here, so the emission is lesser. Nil emission. Okay. The next advantage is lesser land utilization. Lesser land utilization. How do you say lesser land utilization? Windmills are huge, correct? But look at the stem. What is occupying the land? It's just the stem portion, correct? So above the ground, it may occupy a large space, but setting up is very easier. On the ground, inside the agricultural lands, closer to the highway. The picture that you see here, this is taken in Tamil Nadu. There's a place called Muppandal towards southern tip of Tamil Nadu that's known for wind energy production. In fact, it produces one of the highest amount of wind energy in a single place. And if you see here, everywhere, closer to the highway, in all these places, they can erect a windmill. Only the stem portion will occupy the land space, and every other infrastructure is present above the ground. So lesser land utilization. And then any other advantages? Since India is in coastal area, the seasonal variations are lesser. Seasonal variations are comparatively lesser for India. We are not landlocked, no? Seasonal variation is comparatively lesser compared to other nations. Because if you set up in western coast, usually from May or June month, you will constantly have wind because of southwest monsoon. Then if you set up in eastern coast, retreating monsoon. But even if monsoon is not there, wind constantly moves, correct? Land breeze and sea breeze happen. So we will constantly have influx of wind and outflow of wind. Depending on the direction, you can extract electricity. Then coming to the disadvantages. What are the disadvantages? Windmill looks very simple, correct? It spins, makes electricity. What could be the disadvantage? First is initial setup cost. First major disadvantage is initial setup cost. There are companies like Vestas, Siemens Gamesa. They have 2 units, manufacturing units. There is one in Tamil Nadu, closer to Chennai, in Chengalpet. There is one more in Andhra, near Nellore. These 2 places, they're manufacturing somewhere at center of, towards the top of Tamil Nadu. That's where they are manufacturing. But transporting it is not easier. If you see highways, no, they'll be transporting longer windmill blades with full security, because any tiny incident, say it collides on something, and if the blade is bent, that's all, the money is gone. So initial setup cost is higher. When we say initial setup cost is higher, average sized windmill would cost you around 1 crore and 30 lakh rupee. Imagine spending 1 crore 30 lakh rupee on a fan. It is almost the same. So the initial setup cost is much higher. Then next one is logistic constraints. Transportation is difficult. Next disadvantage is logistic constraints. That is, transporting it is difficult. And the disadvantages, it can affect migration of the birds. When you put too many windmills, no, they will find it difficult to fly through them. Many of them may get hit by the windmill and they will die. Because of that, they will change the path. So it will affect migratory pattern of the birds. Affects migratory pattern of the birds. When it affects migratory pattern of the bird, what is the problem? It can affect agriculture also, because if birds are not migrating, it basically means they won't eat the insects from the agricultural field. So if they're not consuming, or if they're not reducing the pest level, what will happen? Again, the agricultural productivity will drop. Clear? I think they have to alter the mic gain. It is causing too much of echo today. ராஜேஷ் சார், மைக் கெயின் கொஞ்சம் கம்மி பண்ண முடியுமா? ரொம்ப எக்கோ ஆகுது. எக்கோ ஒன்று, இன்னொன்று கான்ஸ்டன்டாக ஒரு நாய்ஸ் வந்துட்டே இருக்கு. சும்மா ஒரு பாயிண்ட் கம்மி பண்ணி பாருங்க. அப்படியே கண்டினியூ பண்ணுறேன், சரிங்களா? Okay. So if it is affecting the migratory pattern of the birds, it basically means it's going to affect the agriculture also. That is one problem. The next disadvantage is it audible? Pooja ma'am, is it audible to you? If I reducing the mic gain a little bit.
Yes, sir, audible.
Audible, no? Okay. Audible, no? For you, it's fine, no? They run out of pocket. So if it affects migratory pattern, it also affects the agriculture. Clear? And the next disadvantage is it can affect the wind pattern. Windmill can affect the wind pattern. So what is the problem related to it? Because if the wind pattern is altering, it means it can lead to monsoon failures. Local winds may be altered because it constantly keeps on deflecting the wind pattern. And because of that, on a longer run, it can lead to monsoon failures also. And that is why if you want to install a windmill, no, you cannot rampantly install it anywhere. You have the Ministry of Earth Sciences and then Ministry of New and Renewable Energy. All these people, they do an extensive survey based on scientific data, and then they will label few parts that are suitable for installing the windmills. So if you want to install a windmill, you have to apply to the government. The government will give you the geographic coordinate, and only in those places you would be able to install the windmill. You cannot randomly install it anywhere, because otherwise what we can do across the coastal areas, no, western coast and eastern coast, we have thousands of kilometers. We can just install series of windmills so that a lot of electricity can be produced. But no, artificially altering the wind pattern, it has to be kept in a check. Only a small amount can be installed. And that's why most of the windmills, they are not installed in coastal areas, but instead they are installed in mountain valleys. Example, Udumalpet, closer to Coimbatore. Muppandal, even though it's closer to coastal, but most of the windmills are located a bit inside. So generally in mountain valleys, we prefer to keep the windmills. Clear? Okay. Coming to the next one, we have finished wind energy. Other one is maintenance cost is higher, disadvantage. Maintenance cost is higher for the windmill. But windmill looks very simple. What is the maintenance? Because constantly the insects will strike on the windmill and they will die, which means it forms an organic layer. If you don't clean the organic layer, what will happen? The windmills will spin slower. If it is spinning slower, electricity produced is also lesser. So for that reason, we have to constantly clean the windmill. If you want to clean ceiling fans in your home, how do you clean? Put a table or chair, you can clean it. How do you clean a windmill? There are professionals who actually go to top of the windmill. They will put a rope and then they clean it. No other mechanisms are available right now. One of the highest paid profession, but a risky one too. They have to go to the top of the windmill, put a rope, and then clean it. It's like if you want to clean a windmill today, you won't instantly get a profession. There are agencies that supply these professionals. You have to apply, and then they will give a time slot, and then they will come and clean it. Alternative methods were tried. What if we put a pipe here along with a nozzle? Possible, but you have to put high-powered motors for all these windmills. For every individual windmill, you have to install like a 5 or 6 horsepower motor, and it cannot go beyond the limit also. That is one problem. Then, what if you use a drone? Possible. When the drone is carrying the hose, it's fine. But when the hose starts getting water, what will happen? The weight of the water column, it will cause instability. It will pull down the drone. Other method, maybe you can use something like a fire engine with a ladder and then you can clean it. But again, that becomes a costly process because you have to drive the vehicle all the way up to the windmill. So right now, these professionals are the only options. So the maintenance cost is higher. Clear? But don't keep it as an alternative career option or anything, because this could be replaced anytime soon because of artificial intelligence, or blades may have improved design. All these can replace these jobs. Yes. We have completed till wind energy. Next is we have to talk about energy from sea. Because whenever I teach this topic, in a class full of people, few students will be looking at like, why don't you do this? So they start quickly plotting, exploring that option, but not safe also. That's another problem. Because when you walk on the windmill, they will give you a different type of suit along with hooks. For every step, you have to hook to one loop, and then you have to move to the next one. And then you have to latch yourself to the second loop and then remove the first loop. So it's like you cannot walk faster on the windmill. Moving on the windmill itself, it takes a longer time. So that's why people are not able to clean more windmills in every single day. But because at a high altitude, the wind velocity is higher. Mild instability, if they topple down, then serious consequences. So safety over anything. And because of that, it takes a longer time to clean it. Maintaining it is one of the difficult tasks. Even though the mechanism looks simple, 3 blades and a generator, cleaning is not easier. And these blades are fragile also because they make it with aluminum and other alloys. So it's lightweight, but at the same time, they're stronger. It's like when you bend it, it can return to the position. But when you put too much of pressure, it can break. You take the airplane wings, for example, larger in size, comparatively, their weight will be lesser for flexibility and for efficiency. Similar to that, even the windmill blades, they're lightweight, they're made of alloys, but at the same time, they're a bit fragile also. Flexibility, but also fragile. That's a problem. Right. Coming to energy from sea. There are 3 methods by which you can extract energy from sea. You understood these? Yes. One is we have wave energy, tidal energy, and then ocean thermal energy. There are 3 types. We are going to talk about all the 3. First of all, what is the difference between wave and tide? Even wave, tidal, and ocean thermal energy, correct? What is the difference between wave energy and tidal energy? Wave, tide. When you go to the beach, yes, the water level is not always same, correct? Sometimes the level may be lower, sometimes the level may be higher. That's called as a tide. The vertical movement of the water is called as tide. So this can vary depending on the time of the day, or sometimes it may vary depending on the time of the month itself. You go to Rann of Kutch, Gulf of Kutch and all, periodically it will vary. Every single day there will be fluctuations. That is called as tide. So tide, you remember, vertical movement, up and down movement is called as tidal energy. But when you go and stand in the beach shore, you start getting the waves, that is in horizontal direction. Horizontal movement of direction can be, horizontal movement of water can be called as wave. Vertical movement of the water column can be called as tide. Clear? So what causes the tidal fluctuations? Up and down movement of the water column, what causes it? Gravity. Gravity of the moon and also gravity of the sun. Something is pulling it, no? And that's why if you see the water level will be higher during full moon day, because, and also the moon is closer. So what happens? The water column is being pulled with greater gravity. Water levels are higher. So the vertical movement or the up and down movement of the water depends on gravity of the moon and gravity of the sun. That's called as tide. We can extract energy using tide also. But the horizontal movement that you see, it is because of the wind that moves on the surface of the water, no? It will cause a wave. Even if you see a river or a pond, whenever there's a strong wind, small amount of wave will be created. Now imagine something like an ocean, large waves will be created. So if you extract energy using the horizontal movement of the water that is repeatedly happening every few seconds, that's called as wave energy. But if you use vertical movement of the water to extract energy, that's called as tidal energy. Try reading this once. Tides are caused by gravitational effect. Wave is caused by the wind. So you can put a tabular column. Left side for tidal energy and right hand side for wave energy. Tidal energy and wave energy. So first for tidal energy, you can write energy extracted using vertical movement of water. Energy extracted using vertical movement of water. Wave energy is the energy extracted using horizontal movement of water. So tidal energy uses vertical movement and wave energy uses horizontal movement. Noted? Then you can write tides are caused due to gravitational effect of moon and sun, whereas waves are caused due to horizontal movement of wind over the surface. Caused due to horizontal movement of the wind over the surface. Horizontal movement of the wind over the water surface that leads to wave. Next one, tidal energy. Tide is more consistent, but wave is unpredictable. Tidal variations are predictable or consistent. They have a constant pattern, but wave is unpredictable. Tide is consistent and it's predictable, because if you go to Sundarbans or if you go to Ran of Kutch, they will say exactly at this time of day the water level will be here, and then the water level drops. Or if it is varying based on weeks, they will say this week the water level will be high, the next week water level will be low. We can make a prediction based on the pattern for tidal movement, that is up and down movement. But wave, it depends on wind and it is unpredictable. Tides are predictable, waves are unpredictable. Tides have a constant pattern mostly, but waves do not stick to a constant pattern. Yeah, tides have a pattern, but waves, they do not have a pattern. To understand how it basically works, take a look at this. No, in geography, you would have studied about spring tide and neap tide, or low tide and high tide. That is, first the tide is low. Then when the moon is closer, what happens? The gravity is higher and the water column ascends. The water level is going up. Now you're going to put a gate here, and then you're going to store the water. For storing the water that's given here, did you spend any energy? No. The gravity of the moon and the gravity of the sun, it was pulling the water to a higher altitude. You have closed it with the gate. Then at a later point, you're going to open the gate. When you open the gate, what happens? The potential energy will be converted into kinetic energy. You're putting a turbine here, converted into mechanical energy. Turbines can be attached to a generator, converted into electrical energy. You're producing alternating current here by spinning the turbine. Starting from nuclear energy to almost all the forms of energy, the same principle. You have to spin a turbine. The turbine will be attached to a generator. How you are going to spin the turbine? If you produce steam using fission reaction, nuclear energy. If you produce steam by grinding the coal and burning it, thermal power plants. And then if you spin the turbine using movement of water, then that falls under tidal and wave energy plants or hydroelectricity. That's all. The principle is same, producing AC current using a rotating component. So during high tide, we have stored water here. During low tide, we are opening the gates, and then the water gushes through, potential into kinetic, kinetic into mechanical, mechanical into electrical energy. This is called as tidal energy. Then coming to wave energy. What happens in a wave energy is, we are building a chamber like this. In this, you have air that is stored here. You see this portion. This portion is filled with the air. Now, water gushes through this. Wave is horizontal movement, correct? So when the waves are moving, the waves are gushing inside. What will happen to the air column? Will it get compressed or expanded? Compressed. The air gets compressed. When the air gets compressed, it always tries to find a way to squeeze outside, correct? We are going to keep a hole here. So the water moves inside, it's going to compress the air, and the compressed air is going to escape through the small hole. What is placed here near the small hole? Turbine. Turbines will spin. Turbines can be attached to a generator, produces electricity. This is called as wave energy. So if you notice here, we were using vertical movement of water to store it and then convert into electricity. Here we are using horizontal movement of the water to compress the air and then produce electricity. That's all. Have you understood this? Now coming to tidal energy. If you want to produce electricity using tidal energy, you need higher movement of water up and down, correct? Take a look at this map. The red color denotes higher fluctuation. Where do we have red color? The coastal area? Gujarat, correct? Next to tidal energy, you can write. In India, we have it in Ran of Kutch. Please wait. Space here. Okay, in India, this is there in Gulf of Kutch, then Gulf of Cambay, both in Gujarat. Along with that, we also have the plant in Sundarbans. So why Sundarbans is important? Because India's freshwater tidal energy plant located in West Bengal. We have freshwater tidal energy plants also located in Sundarbans. Noted this? Yes. And coming to wave energy plant. For wave energy, you need high wave velocity, correct? It should come to the shore with greater velocity. That reason, see where we have read? Maharashtra, Kerala, and Tamil Nadu. India's only functional wave energy plant is located in Vizhinjam. Where we have Vizhinjam? port closer to Trivandrum. So Vizhinjam is India's first wave energy plant. Somewhere in the early 1980s itself, we have started. Tidal energy, wave energy. Tides to mostly in Gujarat regions and Kolkata. And then wave energy plants, it's in Vizhinjam in Kerala. Only in Vizhinjam. The wave velocity is much higher. Maharashtra so far only experimental. They have not completed it because it's towards southern tip of Maharashtra near the Karnataka border. No? They have not installed it so far. Same with Tamil Nadu also. See, the experimental, we have tested feasibility and everything, but only functional plant is in Vizhinjam. Can you go to the next? Next is ocean thermal energy conversion. Next concept is OTEC or ocean thermal energy conversion. How we use ocean thermal energy is, let's take the surface of ocean, which is at 25 degrees Celsius, for example. Then when you go to greater depth in ocean, the temperature, will it increase or reduce? When you go deep under the ocean, reduces. You're not going from the ocean floor, only the water column. Surface of ocean is 25 degrees Celsius, but when you go to depth, it may be around 3 or 4 degrees Celsius. So here it is hotter, and when you go inside, it becomes colder. Exactly. Now we are going to use alternative expansion and compression of the gases. So how do we use the alternative compression and expansion is, we are going to set up a network like this. In this network, we are going to pass a gas inside, say ammonia. In most of the cases, they use ammonia. Ammonia is going from hotter region to colder region. So what will happen when it moves from hotter to colder? Will it expand or compress? Compress, because it's cooling down 25 to 3 degrees Celsius. It cools down and it will also turn into liquid, what we call as condensation. The process of converting gas into liquid is called as condensation. Yes. Under greater pressure, we will have different pressure pumps here. Using the pressure pump, we will be pushing the gas through this and then through this. Now it is moving from 3 degree to 25 degree. What will happen? Expands, correct? That is, the liquid will be turned into gas, which we call as evaporation. In this column, the gases are converted into liquid. In this column, liquid is converted into gas. Imagine ammonia gets compressed and then rapidly it expands because of high pressure. When it expands and comes out, we are going to place a turbine here. What will happen to the turbine? Starts rotating, correct? Because it is like ammonia is expanding and with full pressure it's coming out. The turbine starts rotating. Turbines can be attached to generator. Generator can produce electricity. This is how ocean thermal energy conversion works. The basic principle here is, you're not going to burn anything. You're going to use alternative cold and hot layers of the ocean to expand a gas and then produce electricity. Ocean thermal energy conversion. Is it clear? You can copy this alone. Because ammonia can rapidly expand and compress at very low temperature, like 25 to 3 degree. It need not go to like 0 degrees Celsius or anything. Moderate temperature is sufficient to compress and expand it. Right now, we don't have these plants in India, but prospective ideas are this may be installed in Andaman, Nicobar and Lakshadweep. Because how do people in Andaman, Nicobar get electricity? Mostly we run cables from here. And many times they run diesel generators, polluting the ecosystem. So what if we use these methods? We are thinking. There are pumps. If you see here, no, you can understand. You have ammonia pump here. You're taking the cold water and then you're also sending ammonia. Ammonia gets heated, spins the turbine, and then the same thing is again recirculated. We are setting up a cyclic system so that you don't draw too much of resources. You reheat the ammonia again and again. Have you noted this? Which one? Turbine is above the surface. Turbine is above the surface. In air, it is going to spin. Have you noted? Can you go to the next? So followed by this, next we are starting with geothermal energy. Next is geothermal energy. So what happens in geothermal energy? See here, this is ocean thermal, correct? Where do we have higher temperature? Surface. Where do we have lower temperature? Below the surface, deep under the water. Imagine the inversion of this. What if you have high temperature at the bottom and low temperature at the top? That's called as geothermal energy. That is deep inside the earth, and certain places we have geothermal reservoirs. When you say geothermal reservoirs, the places where you have geysers, hot springs, or places where volcanic activity may be there. There are places, especially in the Himalayas, Nordic area, we have temperature that goes up to 3000 degrees Celsius below the ground level. So let's take this is like 30 degrees Celsius, and this is like 3000 degrees Celsius in geothermal reservoirs. You're going to do the same here, but you're going to send a liquid. You're going to send some liquid deep inside. What will happen when it reaches 3000 degrees Celsius? It gets heated, it's about to boil, correct? That one is brought back to the surface. So you're sending cold water or cold chemical here, but here you are getting hotter ones, correct? So this will be used for heating another water. So this is used for producing steam, what we call a steam generator. We'll repeat once again, you're sending cold materials inside. It reaches the geothermal reservoirs, which are having higher temperature, gains the temperature, comes out of the ground, and then this will be sent to steam generation. Yes. When the steam is generated, it will be attached to turbines. Turbines will be attached to generator. Generator will produce electricity. So this is called as geothermal energy. Take a look at this. You have injection well. When we say injection well, you are going to inject chemicals. Do you see geothermal reservoirs here? They will heat, and then production well, the place where the heated water or the chemicals are drawn out. Then what is written here? Heat exchanger that will produce steam, and then you have turbine or generator which produces power. This is called as geothermal energy. So you can write this one. Yes. Natural, yes. That's why I said it's often found in Himalayan regions. There are two important places where we have this. One is Manikaran. Manikaran is present in Himachal Pradesh, away from Shimla. And then you have Puga Valley. Where do we have Puga Valley? In Ladakh. These are the two places where India has geothermal energy plants. Manikaran is not functional right now because of some reason, no official press releases, but Puga Valley is functional. Usually water. And sometimes they use chemicals that will undergo quick expansion. Noted this? Yes. Based on this, next concept is we are to talk about solar energy. Next title is solar energy. So when we say solar energy, when I use the term solar energy, which device comes to your mind? Panels, solar panels, correct? That's what we generally think. True. There are two types by which you can extract energy from sun. One is called as solar thermal energy. The other one is solar photovoltaic energy. There are two types. When you say solar panels, what you basically mean is solar PV panels or solar photovoltaic. And then when you say solar thermal, so this uses mirrors. Do you remember concave mirrors? We discussed about plane, concave, convex mirror, concave and convex lens. When you set up a concave mirror, what will happen? Light falls on this, gets reflected back at a focal point, correct? At the focal point, the intensity is higher, the temperature is also higher. So this is for one concave mirror. What if I keep these many concave mirrors? Thousands of concave mirrors. Imagine the temperature it is capable of producing. And in fact, if you go to European countries, no, they put something like this in front of the buildings, no? They will put completely mirrors. Now, people living inside the building, they will have lesser temperature because the mirrors are reflecting most of the light. But the building that you see here, this is capable of producing up to 2000 degrees Celsius inside. The water boils, produces steam. Steam will spin generator. Generator will produce electricity. So this is called the solar thermal energy. And the other one that you see, this is solar photovoltaic. Clear? So under solar thermal, you can write, in general terms, you can write two types, solar thermal and solar photovoltaic. Solar photovoltaic. Okay. First, put the right less solar thermal energy and write one line, or even below the, this itself you can write. We are writing small definition for this. Solar thermal energy uses series of concave mirrors, to focus or concentrate the radiation. Solar thermal energy uses series of concave mirrors to focus or concentrate the radiation. This produces high temperature. This produces high temperature, which can be used for generating steam, and producing AC current or alternating current. Series of concave mirrors to cause higher temperature, used for generating steam, which in turn produces AC current or alternating current. Noted this? Yes. Next is solar. By the way, this is often found in Rajasthan. Obviously, because you have desert regions, you can put a lot of concave mirrors, and then maintenance is a bit easier. So this is usually found in Rajasthan regions, but very few solar thermal energy plants. We have more solar PV panels. Next is solar photovoltaic energy. The title is solar photovoltaic energy or solar PV energy. For this, extensively we are writing notes. Write it separately. Take the solar photovoltaic energy. Have you heard about something called as semiconductors? Yes. Generally, based on the electrical conductivity, we have three types of materials. We have insulators, conductors, and semiconductors. When we say insulators, will not conduct electricity. Conductors will conduct electricity. Semiconductors will partially conduct electricity. So if you take insulators, say wood or rubber or pure water, all these are taken as example for insulators. Then conductors, any metal, copper, iron, all these are taken as example for conductors. Semiconductors, silicon, germanium, all these falls under semiconductors, which means it will partially conduct electricity in certain circumstances. We're going to learn about semiconductors. Clear? In semiconductors, there are two categories. We have intrinsic and then we have extrinsic semiconductors. Extrinsic semiconductors are further classified into N-type and P-type semiconductors. Altogether, we are going to make two tabular columns. First is, we will classify intrinsic and extrinsic. Then we will learn the difference between N-type and P-type semiconductor. So first tabular column under the topic semiconductors. Topic is semiconductors. The first one is intrinsic semiconductors and then extrinsic semiconductors. Intrinsic and extrinsic. So under intrinsic semiconductors, you can write they're also called as pure semiconductors. They're called as pure semiconductors. And extrinsic semiconductors are called as impure semiconductors. Intrinsic semiconductors are pure semiconductors, and extrinsic semiconductors are called as impure semiconductors. Under intrinsic semiconductor, you can write it's made of single element. Intrinsic semiconductors are made of single elements, but extrinsic semiconductors, they contain impurities. The process of adding impurities is called as doping. In sports, when we say doping, it means usage of banned substances. Very similar to that. In this case, you have an intrinsic semiconductor. Inside the intrinsic semiconductor, you are adding impurities. We are voluntarily adding impurities to increase the conductivity. So the process of adding impurities is called as doping, and the material being added is called as dopant. For now, you can write doping is the impurity that's being added inside. Why we have to add impurities? It's because here you can write intrinsic conductivity. Conductivity depends on temperature. Conductivity depends on temperature. But here in extrinsic semiconductor, conductivity primarily depends on amount of impurities. Conductivity depends on the amount of impurities. Okay, here the electrons equals to number of holes. I will explain what is meant by holes later. In intrinsic semiconductor, the number of electrons and holes are equal. Number of electrons and holes are equal. Coming to extrinsic semiconductor, they have unequal electrons and holes. Extrinsic semiconductor, they have unequal electrons and holes. Unequal electrons and holes. This is generally used for research purposes. Intrinsic semiconductors, they are very sensitive to temperature. They are mostly found in the labs and they are used for research purposes. Coming to extrinsic semiconductors, they are used in manufacturing of diodes, transistors, which means most of your consumer electronics runs based on extrinsic semiconductor. Your mobile phones, laptops, tablets, smartwatches. Extrinsic semiconductor is widely used in consumer electronics since it's used in manufacturing of diodes and transistors, which is generally limited to lab. Intrinsic, which is usually found in the electronics. Extrinsic. Okay, knowing this much is sufficient, you can close the tabular column. Semiconductor is an individual lesson in your NCERT. I've just put a very short summary here. Next is, in extrinsic semiconductor, you have two types of semiconductors, that is N-type and P-type. Next is N-type semiconductor and P-type semiconductor. Both of them fall under extrinsic. Have you heard about something called as valency? Yes, valency is number of electrons in the outermost shell. It's like, imagine something like a racetrack. If you take carbon, C612, how many protons are there? 6. How many electrons? How many neutrons? Very good. Now this is nucleus. This is K shell. And this is L shell. Let's say 6 protons and the 6 neutrons are here. The yellow color highlighted portion denotes it's a nucleus. And then the red color is the electrons. First shell, 2 electrons. Second shell, 4 electrons. We can say the valency of carbon equals to 4 because 4 electrons are available for a reaction here. It will either lose 4 electrons or it will gain 4 more electrons to reach the octet configuration, that is 8, so that it can have stability. If there are only 1 electron in the outermost shell, mostly it will try to lose it because gaining 7 is difficult, losing 1 is easier. You take copper, for example. Copper has 1 electron in the outermost shell. Very easily conducts electricity because when you put a pressure, it won't try to gain 7 electrons, which is more energy consuming, but losing 1 is easier to reach stability. So copper attains stability by losing 1 electron. Now this is called as valency. In general terms, combining capacity of an atom is called as valency. Clear? Here, for N-type semiconductor, you can write pentavalent impurities are added. Pentavalent impurities are added, and for P-type, you can write trivalent impurities are added. N-type pentavalent, P-type trivalent. Pentavalent impurities are added and trivalent impurities are added. Okay. What is the point in adding pentavalent impurities here? Penta means how many? 5, correct? Penta is 5. See here, phosphorus is added. Phosphorus is a pentavalent impurity. 1, 2, 3, 4. How many bonds are formed here? 4. But if you see this electron, this is not forming any bond, which means this is available for recombining with something else, correct? So we can say the number of electrons are greater than number of holes. What exactly is a hole here? Here, aluminum is added. This is a p-type semiconductor. In this, trivalent impurities are added. 1, 2, 3. How many electrons have combined? 3. So the silicon is ready to form bond here, but no electrons are present here. The vacant space is called as hole. Hole is not a physical hole in the semiconductor. It basically means there is a space available for the electron to come inside. That's called as hole. In this case, what is extra? Electron. In this case, holes. So we can say here electrons are greater than the number of holes, and here for p-type, the number of holes are greater than the number of electrons. And that's why in the previous case you have written for intrinsic semiconductor equal number, but for extrinsic unequal, because either the electrons will be higher or the holes will be higher. Clear? This is the second point. You can write this. Noted this. Yeah, we can add one more here. We're going to talk about the pentavalent impurities. What are the commonly used pentavalent impurities here? You can write phosphorus, arsenic, antimony. These are examples for N-type. Then coming to P-type, you can write aluminum, boron, indium, These are examples for trivalent impurities. That is, atoms with 3 electrons in the outermost shell. Trivalent impurities. Right, we can close the tabular column. This is sufficient about N-type and P-type. We are going to learn the solar photovoltaic panel based on N-type and P-type semiconductors. Clear? We can close the tabular column. Next, we are going to learn about PV, solar photovoltaic panels. How a panel works, or how a photovoltaic panel works. If this is the cross section of a panel, on the top, we have N-type semiconductor. If you say N-type, what will be added inside? Trivalent or pentavalent impurities? Pentavalent impurities. And the bottom we have P-type semiconductor. What will be added in P-type? Trivalent. Now, what is extra in N-type? Electron. What is extra in a P-type? Hole. If electron moves, movement of electron is called as electricity. The term electricity itself comes from movement of electrons, correct? So we are going to learn how to push this free electron to this hole, which will create electricity. N-type has extra electron, P-type has extra holes. What is on the top? N-type. What is on the bottom? P-type. And between these two, we are going to keep a junction. When we say junction, this is capable of conducting electricity. Clear? Next step is, we are going to connect this and this. But this is a short circuit. You should put some load here. You're going to put a light bulb or a battery or something. It's kept here. Now, sunlight falls on the panel. So when sunlight falls on the panel from the N-type semiconductor, what is extra in the N-type semiconductor? N-type. What is extra in N-type? Electrons. When sunlight falls with a particular energy, the electrons will be pushed out from the N-type. It will be pushed to the circuit. So the electron starts moving from N-type through the circuit. Movement of electron creates electricity. We have produced electricity here. The electron returns to P-type. It started from which one? N-type. It has returned to P-type. But the circuit is not complete. Circuit is complete only when it joins. We have a junction here. Through the junction, the electrons will again pass. And then again it will reach the same N-type semiconductor. Altogether, it sets up a cyclical motion. Starts from N-type, electrons gets consumed here. Remaining electrons will reach P-type, and these remaining electrons, again it will reach which semiconductor? N-type semiconductor. This is how a solar panel works. Now try checking this one. You have a solar panel. Energy from the light falls on this. Then electrons are freed, correct? The electrons are freed here. They start moving through the circuit. It starts from which one? N-type. It moves to which one? P-type. And then you have a junction at the center. Through the junction, see here it is written on the top N-type, on the bottom P-type, at the center junction. Start from N-type, moves to the P-type. Again, the electrons fills the N-type. This is how a solar photovoltaic panel works. Is it clear? We can copy this. Out of this? Yes. So far you've learned about two types of semiconductor, that is intrinsic and extrinsic. And you've also learned about N-type and P-type. Based on N-type and P-type, you've learned about solar photovoltaic energy. Clear? Try answering this question, 2014 UPSC Prelims. Photovoltaic converts light into electricity. Solar thermal generates heat and then produces electricity. Yes or no? Yes. See the two differences. Solar thermal, you use concave mirror, produces heat and then produces electricity. But here, solar photovoltaic, it converts light into electricity. So the first one is right. Second one, solar photovoltaic generates AC current while solar thermal generates DC current. Other way around, correct? This is a very familiar format in UPSC. They will swap it. Ideally, solar photovoltaic generates DC because it's a static component. And then solar thermal will produce AC because it's a moving component. And then India has manufacturing base for solar thermal, but not for solar photovoltaic. No, we have manufacturing base for both, but demand is far more higher compared to the supply. And that's why we are importing it from China and other countries. The answer here should be 1-1. These are the type of questions you can expect from energy techs. Can you go to the next one? Yes. If you see, we have so far completed all the energy technologies. The last one is electrochemical cell. We have to learn about electrochemical cells. And then we have to talk about lithium ion battery, sodium ion battery, fuel cells, and then electric vehicles, and finally a comparison. That would take around 1 hour. So can we take lunch break a bit earlier today? 2 to 2:30 we'll keep it. So that from 2:30, maybe around 4 something, we will finish this topic. And then we will give a short introduction to ICT lesson. Then in tomorrow's class, we will deal the rest of the topics. Polity 3 to 5. Only one session will be polity. So Pooja ma'am, we'll meet by 2:30. Do you have any doubts so far?
No, sir.
Okay, ma'am. Okay, ma'am. Can you continue? Yes. Pooja ma'am, can you hear me?
Yes, sir.
Okay, ma'am. Okay, ma'am. So first, we're starting with electrochemical cells, and this certain basic terminologies that you may commonly confuse. First is, what is the difference between a cell and a battery? Difference between cell, battery. You want to change something for the wristwatch. Do you change cell or battery? Cell. For mobile phone, batteries. That's because cell basically means a single unit. That is one positive and one negatively charged terminal. You call it as a cell. Collection of cells together. It's called as battery. Multiple positive and negative terminals. For remote, you change battery because generally remote controllers have two cells, correct? When you connect two cells together or more than two cells together, you call it as a battery. So cell is single unit. Battery is a compilation of cells. Similar to that, there is something called as primary cell and secondary cell. Just quick tabular column, small tabular column. Difference between primary and secondary cell. Okay, first cell is single and batteries are multiple. Then we are going to talk about primary cell and secondary cell. Electrochemical cell. Topic is we're learning about electrochemical cells. Okay, then you can write this. And then the classification between primary cell and secondary cell. We understood till this? Next, for primary cell, you can write electricity or current is derived by irreversible chemical reaction. Electricity is derived by irreversible chemical reaction. This is derived by reversible chemical reaction. Primary cell, irreversible chemical reaction. And secondary cell, reversible chemical reaction. Primary cells are economic. These are costlier. The chemical reaction in primary cell is irreversible, secondary cell is reversible. This is economic, and that is costlier. These are generally lightweight. And these are heavier. Secondary cells are much more heavier compared to the primary cells. Okay, then for primary cells, no, we can add one more examples. Where do we have primary cells? Generally, the non-rechargeable cells are primary cells. That's why we say the chemical reaction is not reversible. Irreversible chemical reaction, non-rechargeable cells. Reversible chemical reaction, rechargeable cells. Non-rechargeable and rechargeable. Okay, then for primary cells examples, Daniel cell, Leclanche cell, or galvanic cell. These are examples. Here, lead acid batteries, lithium ion cells, lithium polymer cells. These are examples for secondary cells. We use lithium ion cells in the phone. No? Those are secondary cells. That's why you're able to recharge it. No. So cell battery is about single and double unit. So you can say lithium ion cell or you can say lithium ion battery also. So that is you can say galvanic cell or galvanic battery also. Cell battery is about how much you're stacking. But here it's about the event that happens inside or the process that happens inside. Last one is lithium polymer battery, LiPoL, lithium polymer. Okay. So if you learn about working of a single cell, like one galvanic cell, you thoroughly understand it, remaining will be easier. It's like we are learning the basic one of the primitive or the earliest cells built, and based on that, we are learning about other cells also. Clear? Put the title as galvanic cell, working principle of galvanic cell. The reason we call it as galvanic cell because it was built by Luigi Galvani, who was a Italian physicist. Now, under galvanic cell, we'll take this example. Let's say I have a liquid water here. If I put this metal inside the water, will this metal dissolve? Metal inside water? No. But if I take acid and then if I put the metal inside, yes, it may dissolve. Now, the same metal, under certain circumstances, it's dissolving. Under certain circumstances, it is not dissolving. It depends on the alteration in the electrons. Chemical reactions are not mostly driven by the electrons inside. They're not driven by the protons or neutrons that's present inside the nucleus. Because nuclear reactions, fission, for example, or fusion, those are based on nucleus. But here we are talking only about the electrons. Sometimes the metals may lose electrons. Sometimes the metal may gain electrons. Depending on that, the chemical reactions will happen. There are certain basic things that you should have in mind when you learn about cell. First is stable atoms. I've already written it multiple times, but we are repeating it here. Stable atoms are electrically neutral. What does it mean by this? Stable atoms being electrically neutral. Number of positive charge equals to number of negative charge. And then the next one. Stable atoms make solid metal. So stable atoms make solid metal. But metal ions will dissolve in a solution. So stable atoms make solid metal, but metal ions will dissolve in a solution. Stable atoms make solid metal and metal ions will dissolve in a solution. So whenever the number of positive charge and negative charges are equal, what will be the state? Solid, liquid or gas? It will be solid state. Whenever positive and negative charges are equal, whenever it is reaching stability, stable atoms are in solid state. But when it loses electrons or when it gains electrons, it will dissolve in the solution. Do you have any doubts to these? Okay, next is. Have you heard about a term? Electropositivity and then electronegativity. Electropositivity and electronegativity. The concept of electropositivity and negativity is you have an atom, equal number of protons and neutrons, and also electrons are present outside. For example, let's take this as helium that contains these atoms. How many protons are there? 2 protons. How many neutrons? How many electrons? 2 electrons. First, let's talk about electropositivity. If any idea what does mean by electropositivity and negativity? See, this is an electron. The charge of electron is negative. If this electron is lost, the electron goes outside. What will be the overall charge of the atom? Positive, because 2 positive charge, but only 1 negative charge, correct? I'm saying that this electron moves outside. When this electron moves outside, now the charge of this electron will be negative, but overall charge of this atom will be positive because 2 protons and only 1 electron, correct? So this is gaining what charge? Positive charge. Imagine this scenario, because of some reason, 1 more electron is added inside. In this case, what will be the overall charge? Negative, because how many protons? 2 protons, but how many electrons here? 3 electrons. This is negative. Electropositivity means when something tries to reach positive state, that is tendency to lose electrons. It's called as electropositivity, because when something loses electron, it gains positive charge. Electropositivity is tendency to lose electron, which means electronegativity means tendency to gain electrons. That is, if overall charge becomes negative, that's called as electronegativity. The overall charge becomes positive, that is electropositivity. Clear? You can write this because the entire cell diagrams will be based on these 2 concepts, electronegativity and electropositivity. Noted this? Yes. First, under galvanic cell, let me complete the diagrams totally. You sit and listen, then we can copy it. Clear? We're taking two metals here. Both the metals are immersed in a solution. How many vessels do you find here? Two vessels. How many metals? Two. How many solutions? Two solutions. Generally in a cell, the main aim is, if you see the solar photovoltaic panel, no, you are trying to push electrons from one side to the other side, correct? Movement of electrons costs electricity. That's the aim that we have, very similar to that. Here also we try to push electron from one side to the other side. For that, one electron has to be one metal has to be electropositive, the other metal has to be electronegative. In other words, one should send the electrons, other should receive the electrons. Clear? On this side, we have zinc. Zinc is dipped inside zinc sulfate solution. Clear? On this side, we have copper. Copper is dipped inside copper sulfate solution. Clear? The metal is copper and the solution is copper sulfate. The metal is zinc and the solution is zinc sulfate. When we say zinc sulfate solution, basically it contains two ions inside. One is Zn2 plus, other one is SO4 2 minus, two ions. When we say Zn2 plus, zinc that has lost two electrons, SO4 2 minus is sulfate that has gained two electrons. Only then it will have negative state. No? Similar to that here, copper sulfate. It has two types of ions inside, Cu2 plus and SO4 2 minus. That is copper that has lost two electrons and sulfate that has gained two electrons. Have you understood this? Next, we are going to connect this and this. This is a short circuit. So you are putting a load here. A load is connected here. Have you understood this? Next. First step. What happens at zinc? I'm writing in zinc metal. Now the reaction happens in which one? Zinc metal. Zinc loses two electrons. Zinc loses two electrons. What will form here? Zn2 plus. And I'm writing this zinc, it is stable. If it is stable, it will be in which state? Solid. But this one, it is an ion. If it is ion, what will happen? This will dissolve. Exactly. Zinc used to be solid, but right now it has lost the stability. And then Zn2 plus, the metal starts dissolving and mixing inside the solution. Clear? Already what is present inside? Zn2 plus. Now when it starts dissolving, the concentration of Zn2 plus increases. Have you understood this? Yes. Other than Zn2 plus, what is produced here? Electrons. These electrons, they start moving in this wire. Movement of electron creates electricity. It reaches the other side. It reaches which metal here? Copper metal here. After reaching the copper metal, what happens is these electrons will move and reach the copper sulfate solution. They are reaching which one here? Cu2 plus. Clear? Right now, the next reaction is going to happen in the solution. Here we have written in zinc metal, then inside copper sulfate solution. Because the copper is not reacting here, copper sulfate solution is reacting here. Do you have any doubts to this? No. What are the two things present inside copper sulfate? Cu2 plus, SO4 2 minus. So the Cu2 plus that's present inside the solution, it starts gaining electrons. These electrons, no, they will travel through the circuit. Whatever is left over, it reaches here. This will be converted into Cu. Exactly. This one is an ion. Since it's ion, this will dissolve. But this one is stable. If it's stable, what will happen? This will become solid. Which metal is dissolving here? Zinc. Which is growing here? Copper. That's because whenever it settles here, the concentration of Cu2 plus reduces, and the Cu2 plus that's present here slowly settles on the metal itself. One is dissolving, other one is growing. If you let this cell function for a long time, what will happen? You know, something like this will happen. That is, one metal is completely dissolving. Which metal is dissolving here? Zinc is completely dissolving. Over time, this will start growing in size. Which metal is growing here? Copper is growing here. Okay. Earlier it was like this, it has turned into something like this. Zinc started dissolving, sent electrons, it reached copper, and copper sulfate ions were reducing. This was undergoing a process where it starts dissolving. This was undergoing a process where it was growing. Clear? As long as this process continues, as long as electrons are available for movement, the battery will be active. But once this metal completely dissolves, then the reaction will not happen. This is a primary cell because you cannot reverse this reaction. But if you could connect it to electrical supply, and if you could bring back the electrons back here, then that becomes a secondary cell. That is, the chemical reaction that happened in this direction, it is irreversible. This is a primary cell. If the reaction can be reversed, then it becomes secondary cell. Clear? Now, one metal is undergoing oxidation, other metal is undergoing reduction. You have heard about the concept called as oxidation and reduction. Any idea which is undergoing oxidation or which is undergoing reduction? Which is undergoing reduction? Physically looking at it, zinc, because zinc is reducing in size, but it is undergoing oxidation. Copper is growing in size, but it is undergoing reduction. How to remember this? I will tell you a term that you can remember. That is oil rig. That is oxidation is losing electrons, and then reduction is gaining electrons. Remember this so that you won't forget. Which is losing electrons? Oxidation. Which is gaining electron? Reduction. Which is losing electrons here? Zinc is losing electrons here. Since it's losing electrons here, we can say that this is undergoing oxidation. Which is gaining electrons here? Copper. So we can say copper is getting reduced, or the reaction here is reduction. One end undergoes oxidation, other one undergoes reduction. One loses electron, other gains electron. Zinc is dissolving since it forms ions. Copper is growing because it gains electrons, and ions are converted into stable solid. This is how most of your batteries or cells work. Clear? So you can start copying this under the topic galvanic cell. You noted this. You can write the equations. we completed this? Yes. Based on this, we are going to learn about lithium ion cell. Next is lithium ion cell or lithium battery, which we are using in our mobile phones. What happens in lithium ion? Till now, we were learning about these two, correct? These are half cells because this is one half, this is one half. When you connect them, it becomes a full cell, correct? But in modern days, we don't have two different containers. We use it in a single container. Lithium ion batteries, all these are built in single container. In this, I've written something called as a separator here. I will explain the separator later. Then we are going to connect these two electrodes. When you connect these two electrodes, like the earlier case, it's not going to be the same. This time we have a different circuit. One is for charging, the other one is for discharging. We are going to learn about both. And on one side, we have lithium metal oxide. When we say lithium metal oxide, it can be anything: lithium ion oxide, lithium copper oxide, lithium followed by a metal followed by oxide. There are a set of metals that are suitable for the cell production. It's used here. On the other side, we will be putting carbon or graphite. Understood till this? One side you have lithium metal oxide, other side you have carbon or graphite. Then the electrolytic solution used here is lithium hexafluorophosphate, usually LiPF6. Now let's talk about the reaction that happens here. First, let's talk about the reaction that happens in the lithium metal oxide. This phone, most of your phones use lithium ion cell. If I'm going to connect it to a power source, I'm taking a charger, I'm connecting it to a power source, which means we are supplying electricity to the battery, correct? When you supply electricity to the battery, what happens is lithium metal oxide turn into lithium metal ion along with electrons. So I said lithium metal oxide is turning into lithium metal ions. Now lithium metal oxide, this is stable. If it is stable, it will be having which form? Solid. But this one, lithium metal ion, this is an ion. Ions can dissolve. This can dissolve in a solution. So when it is dissolving in a solution, slowly over time, this metal is dissolving because ions are increasing. Clear? And then the electrons that are generated here, that is these electrons, they will start moving in this circuit. Movement of electron creates electricity. Electrons go to the graphite. No reaction happens in the graphite because if you see the earlier case, no, we said one is undergoing oxidation, other is undergoing reduction. On the other side, something was growing or shrinking, correct? But here, when the electrons go and settle on the other side, it's more like a container. That is, it's just going to store the electrons here. Carbon is going to accumulate the electrons here, but no reaction happens here. Have you understood this? Then we are going to remove it. That is, you are going to remove the charger. When you remove the charger, during the discharge process, what happens is electron starts moving in the circuit, but in opposite direction. It moves in the opposite direction, and then it reaches the solution. When it reaches the solution, what will happen? This will gain electrons, and then again it will turn into lithium metal oxide. So during charging process, lithium metal oxide is dissolving. During discharging process, the same lithium metal oxide is growing. Which metal is undergoing oxidation here? Lithium metal oxide. Which is undergoing reduction here? The same lithium metal oxide. Since oxidation and reduction happens in the same site, we call it as a redox reaction. Oxidation plus reduction. Together it's called as redox. In this case, is there any reaction that's happening there? No, it is just storing it. But the movement of electron causes electricity. Charging process, left to right. Discharging process, right to left. Charging process, metal oxide is converted into metal ion. Discharging process, metal ion is converted into metal oxide. But then what are the challenges in building this one? So do you see a separator here? Separator will prevent short circuits because this metal and this metal should not come in contact with each other. This is the aim we have. Now, what is the main problem related to lithium ion battery is, which is dissolving here? Lithium metal oxide. Which is growing here? The same lithium metal oxide. And if you see, lithium is the lightest metal in the entire universe. That is, the first one, hydrogen, that is gas. Second element is helium, that's also gas. But lithium, it is the third one, and it's a metal. So which means lithium has 3 protons, 3 neutrons, and 3 protons, 3 electrons, and 4 neutrons. Li3,4, which means this is a solid. The problem here is when it shrinks and grows, that is when it dissolves and grows, something like this will happen. Do you see here? When they are growing, they won't grow in a linear manner, but instead they will start forming fringes. That is, in this, if it is repeatedly shrinking and growing, this will start forming tiny fringes, which will pierce the separator. After piercing the separator, this will slowly come in contact with the other side. So the metal, at some point, it comes in contact with the other side, leading to short circuit. This short circuit can cause fire. The main reason why lithium ion or lithium metal oxide, the batteries undergoes combustion processes, mainly because of the fringes. As long as it is like this, no problem. But repeated charging and recharging process eventually can lead to formation of whiskers or fringes like this. It is going to pierce the separator, like it's going to break the separator, goes to the other side, and short circuit can cause fire accidents. This is the first problem. Second problem is in lithium hexafluorophosphate, it can form poisonous fumes. That is, poisonous gases can form. And that's the reason, have you seen some batteries will swell? That's because repeated charging and recharging, sometimes when the fume forms, it starts swelling, the gases are trapped inside. And that's why they will say not to puncture the batteries, because those are poisonous fumes. There will be a disclaimer written, do not puncture even if empty. That's because if you're going to puncture it, the poisonous gas will come out. It can cause blindness and many other problems. So that's why we should never puncture a cell. Even though in childhood you would have tried to open the cell and all, that's tiny one, it's fine. But lithium ion batteries and all, you should never try to open it because they can cause fire accidents. Clear? So the problem in the lithium ion battery is not related to the anode or cathode. It's actually related to the electrolytic solution, which causes poisonous fumes, and then related to this one that causes fringes. Is it clear? Can you go to the next one? You can copy this first. Oxidation plus reduction reaction. Noted this? Okay. We have completed galvanic cells and lithium ion cells. Based on that, the next concept is there is a new trend, something called a sodium ion cell. You don't have to write it, but you can just understand what happens here. The problem is related to lithium because lithium is not abundantly available and often called as the white gold. Chile, Argentina, Bolivia, Australia. These are the places where we have a lot of lithium. Lithium is also very light, no? But instead of that, we are planning to do something. Instead of lithium metal oxide, we will be using sodium metal oxide. Similar to that here, instead of lithium hexafluorophosphate, we will be using sodium hexafluorophosphate. Everywhere you find the lithium, instead of that, you're going to replace it with sodium. The advantage of this battery is, you see here, Na plus, TF6 minus, almost the same, but only difference is the the metal that's being used here. Instead of lithium, we are using sodium here. The advantage of these type of batteries, first, it's non-aqueous and it's much more safer. It won't produce poisonous fumes. It's more economic, and energy efficiency, it is up to 80% compared to the lithium ion batteries. So you're going to have lesser cost for the vehicle or a battery, but at the same time, almost 80% efficiency. If you take the Tata Nexon EV, for example, we'll take that as an example. The cost of the vehicle is 19.99 lakhs, approximately 20 lakh for a EV Max. In this EV Max, no, the cost for replacing the battery, it's around 6 lakh rupee. Imagine 25% of the cost of the vehicle actually goes into battery. The main reason why people are reluctant to accept the electric vehicle is cost of the battery. And what if there is a need for replacing the battery, which is a costly affair, be it Tesla or any vehicle, it is going to be more costlier. So instead of that, we are planning to introduce sodium ion batteries, which will be much more cheaper. Imagine putting just 30 or 40% of the cost compared to the lithium ion batteries, but 80% of energy efficiency. So this is often seen in the news. Just understand there is a type of battery called a sodium ion battery. Okay? Next is called as fuel cell. Next topic we are going to talk about is fuel cell. Understand the concept of fuel cell. Okay. You heard about the concept called as refueling and then recharging, correct? If your bike runs out of petrol, will you recharge or will you refuel? Refuel, correct? That's called as, like, refueling basically means you're going to fill a petrol or a diesel inside. If your phone runs out of battery, will you refuel or will you recharge? Recharge. So recharging means you have to connect it to a AC or a DC supply, put electricity inside, you call it as recharging. But if you open a fuel tank, put a petrol or a diesel or hydrogen inside, you call it as refueling. But imagine a concept where you have a battery which needs refueling. You're not going to recharge the battery, but you're going to refuel the battery. So how this refueling how the fuel cells work basically? Take, you have a container. In this container you have most common fuel used in the fuel cell is hydrogen. We call it as hydrogen based fuel cells. Cold. I asked for a coffee. So you have hydrogen. Hydrogen is H11. How many protons are there? 1. How many electrons will be there? 1 electron. Now this is going to be oxidized. When we say oxidation, what happens is protons and electrons are separated. Oxidation is gaining electron or losing electron? Losing electron. What happens when you lose 1 electron that you have? Will be left over only with proton, correct? This is also written as H plus because hydrogen loses 1 electron, which is nothing but a proton here. Have you understood this? Yes. We take a cell here and then we have something called as separator. Understood this? First, we are going to give hydrogen fuel. So hydrogen fuel is introduced inside. The hydrogen reaches here. Hydrogen undergoes oxidation. That is, When hydrogen undergoes oxidation, what will happen? It will form one proton and one electron. Then we are going to join these two electrodes along with the load here. Then the electrons starts moving here. Movement of electron creates electricity. So the electrons were formed here. The electrons have moved from one terminal to the other terminal. Electricity has been created. What is left over? Protons, correct? These protons which are present here, what we call as H plus, these protons, they will also move, but not through the circuit, but they will move in this direction. Through the separator, they will move to the other side. So hydrogen was turned into one proton and one electron. Electron has moved through the external circuit producing electricity, and the protons have moved internally through the cell reaching the other side. This and this will recombine. What will be formed again? Hydrogen will be formed again. Along with it, we are also letting oxygen inside. So this oxygen is generally taken from the atmosphere. Oxygen is taken inside. Hydrogen is let inside, oxygen is combining. Hydrogen and oxygen will combine to form. What will be formed usually? Small amount of water vapor or water droplets will be formed. The only output of this cell will be water. Imagine a cell, you're giving hydrogen, the cell produces electricity and the cell lets out small amount of water vapor or maybe small amount of water droplets. This is called as fuel cell. The reason we call it as a fuel cell is you are refueling, you are not recharging. Is it clear? This is a very, a sophisticated technology and a costly one also. So they won't ask you about the anodes, cathodes or anything. You just understand the mechanism. Based on this, we have to learn about electric vehicles. Now, if this, yeah, I will tell you. If this is very easy like this, why is it costlier? That's because the process again, we're giving hydrogen here. How many protons in hydrogen? 1. How many electrons in hydrogen? 1. In this side, oxidation happens. Oxidation is losing electron. The electron that is lost, it travels through the external circuit, causing electricity. What is left over here? Protons. The protons will reach through the separator. Protons are reaching the other side. Electrons are also reaching the other side. They will recombine to form hydrogen. Also, it combines with oxygen. Hydrogen and oxygen combines to form water. You have produced electricity, you have produced a small amount of water vapor. This is called as a fuel cell. You are supplying only hydrogen. Oxygen is taken to the atmosphere. Imagine you have a battery. One side is attached to hydrogen, other side is facing the outside environment. What will happen? It will take oxygen automatically from the atmosphere. So this is called as a fuel cell. So why the fuel cells are costlier? The prime reason is for oxidizing the hydrogen, you need platinum nanoparticles. Imagine putting platinum inside a battery to oxidize hydrogen, and that's why hydrogen-based fuel cells are more costlier. Commercially available, but it is not democratized or it is not widely used. It has a very niche application. We'll talk about it. Yes, you can copy this one. What is the doubt here? No, I kept it so that you will understand that it is separated into one proton and one electron. This is hydrogen. Hydrogen turns into proton and electron. Because if I vaguely draw it in the board, no, you may not understand. That's why I put the box. The box doesn't represent anything. Have you noted this? Yes. Now see the picture that's given here. Fuel in and the excess fuel goes outside. Hydrogen is turned into protium ions and then electron. Electron goes to the other side, air gets in, combines and forms water. Is it clear? So it is sufficient to learn about these types of cells. We will try playing a video related to the batteries. Why these fuel cells are more important? That's because this. We are going to have green hydrogen powered fuel cell electric buses. You have seen electric buses in Delhi. Most of them are powered by normal AC supplies or DC supplies. But what if you put hydrogen inside? They're not going to burn hydrogen. Hydrogen is going to produce electricity, and then electricity is used for driving the vehicle. That's called as a fuel cell electric vehicle. We're planning to introduce it in Delhi and other areas eventually. Clear? Yes. Then, how a battery works or how a cell works. Supposed to load. Yeah. It will be a very quick revision for whatever you have learned now.
You probably know the feeling. Your phone utters its final plaintive bleep and cuts out in the middle of your call. In that moment, you may feel more like throwing your battery across the room than singing its praises. But batteries are a triumph of science. They allow smartphones and other technologies to exist without anchoring us to an infernal tangle of power cables. Yet even the best batteries will diminish daily, slowly losing capacity until they finally die. So why does this happen? And how do our batteries even store so much charge in the first place? It all started in the 1780s with two Italian scientists, Luigi Galvani and Alessandro Volta, and a frog. Legend has it that as Galvani was studying a frog's leg, he brushed a metal instrument up against one of its nerves, making the leg muscles jerk. Galvani called this animal electricity, believing that a type of electricity was stored in the very stuff of life. But Volta disagreed, arguing that it was the metal itself that made the leg twitch. The debate was eventually settled with Volta's groundbreaking experiment. He tested his idea with a stack of alternating layers of zinc and copper, separated by paper or cloth soaked in a saltwater solution. What happened in Volta's cell is something chemists now call oxidation and reduction. The zinc oxidizes, which means it loses electrons, which are in turn gained by the ions in the water in a process called reduction, producing hydrogen gas. Volta would have been shocked to learn that last bit. He thought the reaction was happening in the copper, rather than the solution. Nonetheless, we honor Volta's discovery today by naming our standard unit of electric potential the volt. This oxidation-reduction cycle creates a flow of electrons between two substances, and if you hook a light bulb or vacuum cleaner up between the two, you'll give it power. Since the 1700s, scientists have improved on Volta's design. They've replaced the chemical solution with dry cells filled with chemical paste. But the principle is the same. A metal oxidizes, sending electrons to do some work before they are regained by a substance being reduced. But any battery has a finite supply of metal, and once most of it has oxidized, the battery dies. So rechargeable batteries give us a temporary solution to this problem by making the oxidation reduction process reversible. Electrons can flow back in the opposite direction with the application of electricity. Plugging in a charger draws the electricity from a wall outlet that drives the reaction to regenerate the metal, making more electrons available for oxidation the next time you need them. But even rechargeable batteries don't last forever. Over time, the repetition of this process causes imperfections and irregularities in the metal's surface that prevent it from oxidizing properly. The electrons are no longer available to flow through a circuit, and the battery dies. Some everyday rechargeable batteries will die after only hundreds of discharge-recharge cycles, while newer advanced batteries can survive and function for thousands. Batteries of the future may be light, thin sheets that operate on the principles of quantum physics and last for hundreds of thousands of charge cycles. But until scientists find a way to take advantage of motion to recharge your cell battery, like cars do, or fit solar panels somewhere on your device, plugging your charger into the wall, rather than expending one battery to charge another, is your best bet to forestall that fatal bleep.
Okay. Have you understood the concept? Yes. The ultimate aim of a battery is creating electrons, pushing from one metal to the other metal, so that the movement of electrons will create electricity. Based on this, the next concept is electric vehicles. So, tell me example for electric vehicle. Yes. Generally, example for electric vehicle. Name. Just, yeah, Tata Nexon EV, Tata Punch EV, Tesla, Morris Garages is there. So basically, all the electric vehicles that we usually see, it belongs to one category called as BEV, that is battery electric vehicle. So other than battery electric vehicle, we have something called as hybrid electric vehicle. Then you have something called as FCEV or fuel cell electric vehicle. Then you have something called as plug-in hybrid electric vehicle. There are 4 different types of electric vehicles, many types, but 4 major types of electric vehicles. How we are going to learn this is just the block diagram on how it works, and then some Indian examples. First, we start with the BEV, battery electric vehicle. First concept is BEV, battery electric vehicle. So what happens in a battery electric vehicle is, whenever we put an arrow mark here, it basically means the input has to be provided by you. Do you see something called as a battery pack here? Next to the battery pack, we have given arrow mark, which means battery has to be recharged manually by you. Once you recharge the battery packs are attached to electric motors. Electric motors are attached to wheels. The wheels spin using electric motor, which in turn uses battery packs. This is called as battery electric vehicle. So altogether in this block diagram, what we have noticed here is no internal combustion engines are used here, which also means no petrol or diesel or any forms of fossil fuels are used here. Here, no engine and no fossil fuel. This is how it works. First, you copy this, then we can go to the remaining concepts. BEV or battery electric vehicle. Noted this? Any other doubts? You're trying to draw the tires. Okay. Tires are optional, but the block diagrams are compulsory. Okay. Some of the examples for the vehicles, battery electric vehicles. Everyone tells Tesla. Tesla is also opening in India very soon. They're hiring people. But Tesla is familiar for its fast performance, no? But in reality, Tesla doesn't make the fastest electric cars. Have you heard about a company called as Rimac? Why we are talking about Rimac here is to understand how faster the electric vehicles can be. Rimac has a model called as Nivera. Yes, Nivera has 22 world speed records. Look at the records here, 0 to 100 in 1.8 seconds. Imagine going from 0 to 400 in just 21 seconds. You can go up to 400 kilometers per hour. And then 0 to 400 and again applies brakes and comes to 0 in 29.93, which means less than 30 seconds. Imagine you can go up to 400 kilometers per hour. And again, you can reduce and stop at to 0 kilometers per hour. Rather than that, quarter miles and a lot of speed records. Altogether, how many records? 22 speed records. Right now, they have 23 speed records. The third record is the car that can go in reverse with the highest velocity, 275 kilometers per hour. No one is going to take reverse at 275, but still they achieved it. That's because it runs on electric motors, which deliver the power very quickly to the wheels. That's the reason generally electric vehicles have a faster pickup. Clear? Tesla, Rimac, and an Indian example, whenever you see the term EV towards the end, two-wheelers such as Ather, Ola S1, and you have Morris Garage's ZS or Morris Garage's Comet. There are many electric vehicles in the market. These are some of the examples. Coming to the next one, hybrid electric vehicle. So what happens in HEV or hybrid electric vehicle is, take a look at this one. Do you see a fuel tank here? Yes, next to the fuel tank, we have put an arrow mark, which means we have to fill the fuel. And the fuel tank is attached to a engine, which means engine is present. Fuel tank is also present. But when the engine is rotating, we are going to attach it to a generator to produce electricity. And then do you see battery packs here? So engine is spinning. The rotation of the engine is used for recharging the battery. The battery will again drive electric motor, which is attached to the wheel. I'll repeat the process once again. You have two things like this. First, the engine is rotating. The rotation of the engine is connected to a generator. Generator will produce electricity that is stored in a battery. Now, the battery power is used for driving a motor, which is again connected to the wheels. So, engine is driving the car, but you have additional battery that can drive the car even more faster. But do you see arrow mark near the battery? No, which means the battery need not be recharged by you, but the batteries are automatically recharged during operation of the vehicle. Even in this video, no, they were telling towards the end, because the scientists take advantage of motion to recharge the batteries. Here you are using the motion to recharge the batteries. In my opinion, this is the best suited vehicle for the Indian market, because why people are reluctant or to accept electric vehicles? Charging infrastructure. What if I run out of charge somewhere in the middle? That's the biggest problem we have. And also, what if there is a longer wait queue for recharging the batteries? But here, you don't have to recharge the battery in a station. It is automatically taken care of. This is called as a hybrid electric vehicle. It will have better mileage, it will have better pickup, but at the same time, lesser emission also. Examples for this, we have the Honda City HEV, and then you've heard about the recent Toyota Innova? Yes, Innova High Cross. And then Toyota has something called as High Rider. Maruti Suzuki Grand Vitara. All these falls into hybrid electric vehicle. That's the reason if you take Innova Krista, if you use diesel, maybe up to 10 to 13 kilometers per liter for 1 liter of diesel. But this runs on petrol and can give up to 20 kilometers per liter. For a huge vehicle like Innova, delivering 20 kilometers per liter is possible only if you switch to hybrid. Similar to that Honda City. This Honda City can deliver up to 27 kilometers per liter, which is much higher than many of the bikes that runs in the city. It can give up to 27 kmpl. That's because, but at the same time, it's costlier. You can buy a petrol vehicle for 15 lakh, the same variant, but with a battery inside, it costs around 22 lakh. You are paying 6 to 7 lakh extra. That is Honda City HEV. It's at least 6 lakh extra compared to the normal petrol variant. But if you're operating it for a very long time, if you're a frequent driver who logs more kilometers, then this is beneficial. So comes at a cost. It is comparatively costlier, but at the same time, you don't need charging infrastructure. Fuel efficiency is higher. These Honda City HEV, for example, less than 40 km per hour. If you're moving in Delhi traffic, bumper to bumper traffic, it will run on battery. It won't use the engine. Engine will be turned on, but the clutch plates will not be engaged. It's like it's in idle condition. Idling condition, somewhere at 600 or 800 RPM, the engine may rotate, but you don't have to rev it. That is, you can move using battery. But when you demand more power by flooring the pedal, then quickly the engine will be engaged. The car will run on engine. So you have the option to switch both at a time. It can operate both at a time. That's why the efficiency is higher here. It's internally managed. If the battery is running low, then the engines will be completely engaged trying to recharge the battery. But if battery is full, then engine will be turned on, or sometimes it's in deep hibernation mode, and the battery will drive the vehicle. The module decides which one to engage. Is it clear? Have you written the block diagram? No, you can copy. Noted this. Yes, you also have written the examples. So far, you've learned about two types of electric vehicles. Coming to the next one, we're going to talk about something called as plug-in hybrid electric vehicle. So what happens in a plug-in hybrid electric vehicle is, do you see fuel tank here? Next to the fuel tank, we have arrow mark, which means fuel has to be filled. Next to the battery also, we have arrow mark, which means you have to recharge it. You have to manually recharge the battery. You have to manually fill the fuel. Fuel is connected to engine. Battery is connected to electric motor. they coordinate and run together, which means more power, more mileage. There are vehicles that can run up to 1,000 kilometers in a single refuel and recharge. Imagine one refuel, one recharge can go 1,200 plus kilometers. That's called as plug-in hybrid electric vehicle. But it's like combining both, correct? If I hide this, it's completely internal combustion engine vehicle. If I hide this, it's completely a battery electric vehicle. It's like you're clubbing both the vehicles together, making them more and more costlier. Have you ever seen a vehicle like this? No, usually they will have something like this. You see this? Front slot or anywhere they will put a charging. At the same time, they will also fill fuel. Very rarely seen. In Delhi, there are many vehicles. Or if you go to Mumbai, Sachin Tendulkar will have one. And then you have the McLaren P1. You heard about this? This is an example for plug-in hybrid electric vehicle. And then you have the BMW i8, which is a very familiar model of plug-in hybrid electric vehicle. So mostly owned by rich people or millionaires, because for obvious reasons, you're combining both the cars together. This is not generally for efficiency, but for higher power and longer range, making them more costlier. You cannot get a plug-in hybrid electric vehicle for less than 60 lakh, minimum 60 lakh. So that's why it is limited to elite customer segment in general. Clear? You can write this one, PHEV or plug-in hybrid electric vehicle. Noted this? Yes. Followed by this, the next one. Last type of electric vehicle we are going to talk about is fuel cell electric vehicles, or FCEV. Do you remember the concept called as fuel cell? What was given as fuel for the fuel cell? Hydrogen. See here, arrow mark near hydrogen tank. Hydrogen tank is connected to fuel cell. Fuel cell produces electricity, which is stored in battery. Battery drives the electric motor. So this is also electric vehicle, but the difference is you're not going to recharge the car, but you're going to refuel the car. You're refueling with hydrogen, but still it runs on electric power. How? Hydrogen is converted into electricity by fuel cell, which is stored in a battery. It's more like a small reactor inside your car itself. But a reactor that converts hydrogen into electricity, and then it drives the electric motor. That's called as fuel cell electric vehicle. Very rarely seen, because I told you, the fuel cell uses platinum nanoparticles and everything, make it more costlier. Some of the familiar examples, Honda has something called as Clarity. Then Toyota, most famous model across the world right now is Mirai. Then Hyundai, something called as Nexo. These are some of the examples. So Mirai you can see often in closer to Parliament, because the Union Home Minister, the Road Minister, so Nitin Gadkari, he owns a vehicle powered by hydrogen. That's because the government is promoting hydrogen, and it is given by a company, and this is a fuel cell vehicle. So they fill hydrogen for this car, but the car uses hydrogen to produce electricity. Literally, this is electric vehicle that runs on a fuel. That's why it's called as fuel cell. Clear? Yes. You can copy this. Noted this. Right. Okay. Done? Based on this, next we are going to discuss about petrol and diesel. You can make a tabular column. The difference between petrol and diesel. When we say that we are going to compare petrol and diesel, two things. One is we are comparing the chemical nature of petrol, diesel, but also we are going to compare the petrol and diesel vehicles altogether. There are many myths that are related to petrol and diesel. While everyone is concentrating about electric vehicles, what if they ask a question related to BS6 vehicles about petrol, diesel, energy efficiency and everything? So we are going to learn this. Wait a minute. Yeah. Now, when you want to compare vehicles, it will not be justiciable if you compare a lorry that runs on diesel and then a car that runs on petrol, correct? When we are comparing petrol and diesel, we're going to take same model vehicle that has both petrol and diesel variants, say Kia Seltos, petrol diesel, or Hyundai Creta, petrol diesel, Tata Nexon, petrol diesel. Like this same segment vehicle with petrol and diesel, we are going to make a comparison. First, compared to petrol and diesel, can you say which has higher density? Petrol or diesel, which has higher density, that is kilogram per meter cube? Petrol or diesel? Petrol, sure. Diesel or petrol? And right, petrol has lesser density, and then diesel has higher density. There are many myths we generally believe about petrol and diesel. We'll break it one by one. Okay. Then, which has higher energy density? That is, for every kilogram you burn, it should produce more energy, petrol or diesel? Which will produce more energy? Random guesses. Sir. UPSC gives you 4 options. I give you only 2. Petrol or diesel? Which has higher energy density here? Diesel or petrol? Okay. Diesel has higher energy density. How you can easily remember this is, cars are running mostly on petrol, but then if you take trains, trucks, lorries, all these, buses, all these are running on petrol or diesel? Diesel, because they need more energy. You can write energy density is lesser for petrol and higher for diesel. Energy density is lesser for petrol and higher for diesel. Then, ignition temperature. When we say ignition temperature, the temperature at which the fuel ignites, which will have higher ignition temperature? Random guesses. Which will need more temperature to burn? Petrol or diesel? Diesel. Okay. Can write. Petrol has higher ignition temperature. Diesel has lesser ignition temperature. Petrol has higher ignition temperature. Diesel has lesser ignition temperature. So why you said petrol? Because, I mean, why you said diesel will have higher ignition temperature and petrol will have lesser? Because maybe petrol will easily catch fire, correct? That's the assumption we have, which is true. Petrol will easily catch fire, but still the ignition temperature is higher. So why petrol easily catches fire is, if you have ever seen vehicles filling petrol, no? When they are filling petrol, it will turn into vapor, correct? They will quickly close the fuel tank. Even when they are filling it, if it's a sunny day, you will see from the shadow, you can visibly see that petrol is being converted into vapor. This property is called as volatility. But for diesel, diesel looks more like a normal watery liquid, blue green color. And then if you leave the diesel in open space, it won't evaporate as quick as petrol. It will not turn into gas that quicker. So petrol has higher volatility. Highly volatile, less volatile. Since diesel is less volatile, it won't easily catch fire. But petrol is highly volatile. It quickly turns into vapor. It mixes in air. So a small spark, what will happen? It will catch fire. Which has higher ignition temperature? Petrol. But at the same time, which has higher volatility? Petrol. So which will catch fire easily? Petrol. Do you know why energy density is higher for diesel? Let's talk about the carbon atoms. Petrol will generally have 4 to 12 carbon atoms. The main chain, they'll have 4 to 12 carbon atoms. Diesel will have 12 to 20 carbon atoms. Which is having more carbon? Diesel. So which will have higher energy density? Diesel will have higher energy density. Okay. Then let's talk about the engines. Petrol and diesel engine comparatively. Which will be larger in size? Petrol or diesel? Bigger engine. Diesel engines, correct? We call it as CC. Generally, we say 100 cc engine, 200 cc engine. Displacement. Displacement is the size of the engine. Displacement will be lesser for petrol and usually higher for diesel. Displacement is the space available inside the engine. When we say 1.2 liter engine, it basically means 1200 cubic centimeter. That is the capacity of the engine. But mostly for the same vehicle, if it is diesel variant, it will be like 1.6 liter engine or 1600 cc engine. So cc is the cubic centimeter, the space available inside the engine. Clear? Next, we talk about torque. How do we define torque? Turning capacity is called as torque. That is when you open a door, you're going to push the door, but the door swings like this, very similar to that. You're going to put a force on the engine, but the engine is going to rotate, correct? That force is called as torque. In simple terms, we can take torque as a pulling capacity. Higher the torque, higher will be the pulling capacity. Compared to petrol and diesel, which will have higher torque? Diesel. Torque is lesser for petrol and torque is higher for diesel. Diesel, which can be plainly translated as pulling capacity, is higher for diesel engines and lesser for petrol engines. Okay, next, let's talk about the pickup. How fast it can reach, say, 100 kilometers per hour. Petrol or diesel? Which will have higher pickup? Diesel will have higher pickup. Generally, we call it as brake horsepower is lesser for petrol and more for diesel. See, torque is generally measured in Newton meters. Newton meters, how much force is giving. And pickup is generally measured in brake horsepower. That is written as brake horsepower, or sometimes they use the term PS. Brake horsepower is about pickup. how faster the engines can reach high velocity. So if you take a truck engine, trucks don't have the necessity to quickly reach 100 kilometers per hour. So truck engines are tuned to have more torque, but lesser brake horsepower. But if you take a race car is not going to need a pulling capacity. Those will have lesser torque, but comparatively more brake horsepower. You can tune an engine depending on the cycle. You can either put more brake horsepower or you can put more torque. You take ship engines, they will have more torque because they need pulling capacity. Lorry engines, more torque. So torque is about pulling capacity and brake horsepower is about how fast it can accelerate. Clear? Next. Then if you take petrol engines, how the fuel burns inside the engine. Yeah. Usually inside a petrol engine, you see this? What is written here? Spark plug. Generally, when the bike is not starting, we will check the spark plug, correct? The function of the spark plug is, have you heard about 4-stroke engines? What are the 4 strokes in engine? 1, 3, and 4. The first stroke is called as intake stroke. When we say intake, air and fuel will be drawn inside. Second one is called as compression stroke. When we say compression, fuel and air mixture is compressed inside. The third one is called as combustion stroke. That is, fuel will burn inside. And the fourth one is called as power delivery stroke. Delivery, or we can say exhaust stroke. You see here, look at all the 4 phases. Numbers given here. 1, 2, 3, 4. 4 is exit. 1 is entry. 2 is compression. 3 is combustion. 4 is exit. Do you see 4 phases? And when does the combustion process happen here? Which phase? 3. 1, 2. Spark plug here causes the combustion, correct? Spark plug is used for combustion of fuel in petrol engines. You can write spark plugs are used for the combustion of air and fuel mixture inside engines. Then here, high compression for diesel engines, you can write high compression causes combustion of fuel. High compression causes combustion of fuel. High compression causes combustion of fuel inside the engine. High compression causes combustion of fuel inside the engine. Which means, do you see spark plug here for diesel engine? No, they are having more CC, correct? 1200, 1600. They're tall engines, they have more space inside, they have more compression, and because of high compression, the fuel will automatically burn. And also you can connect it with the ignition temperature. For diesel, ignition temperature is lesser. A quick compression can cause the diesel to burn. In fact, if you see compression ratio, that is initial volume to the maximum compressed volume, generally petrol engines will have 1:8 compression ratio. Compared to 8 parts, up to 1 part it will be compressed. But for diesel engines, it can go up to 1:20 or 1:24 ratio. Very high compression ratio, leading to rapid combustion of the fuel inside. Clear? Yes. Then you can write petrol engines eco-friendly. In comparison, petrol engines have lesser emission of toxic gases. Eco-friendly, lesser emission of toxic gases. Petrol engines, lesser emission of toxic gases. Diesel engines emits more toxic gases. Diesel engines emits more toxic gases. Diesel engines emits more toxic gases. Noted? Yes. Generally, petrol engines are naturally aspirated. When we say naturally aspirated, it draws air from the atmosphere and then it burns the fuel. Naturally aspirated or naturally it gets the air. Then coming to diesel engines, most of them have turbo inside. Most of the diesel engines are turbo powered engines. What does mean by a turbo? Generally, diesel engines, something like this will happen. Usually in a petrol engine, when the engine burns and sends the power here, the exhaust gas goes through the tailpipe. When you start the engine, you have a tailpipe, through which the smoke comes out. This normally happens. But for diesel engine, the smoke will not be let out instantly, but they have something called as EGR, exhaust gas recycling, along with the turbo module. Take a look at this one. The engine is sending exhaust here, correct? The exhaust goes to what? Turbo. This is the turbo unit. So the exhaust gas, it goes to the turbo unit, which will cause the turbo unit to spin. Do you see this one? There is a fan here. Yes, the same is given here, turbine. Now, the engine is rotating and then it produces exhaust. The exhaust causes a compression and then more air is let inside the engine. So, it is like engine produces gas, goes into turbo, comes back into the engine again it produces more power and then it is exit. So, you reuse the exhaust gas once before letting it outside. These are called as turbo powered engines. The turbo, do you see turbine here? The turbo will spin faster, it will compress and put more air inside, but it's a more complicated mechanism. That's because, see, that's why they say diesel vehicles, slowly they will go faster. This is a very familiar term they use because at low speeds, it will have more pulling power, but it won't go faster. But once you reach, say, 1500 or 1600 RPM, then instantly you'll get a push. That's because turbo generally onsets or it opens when you are running at a higher RPM, not at a lower RPM. If you're driving in a traffic, the turbo will not engage. But when you want a quick pickup, say you put it on second or third gear and then you give a completely floor the pedal, then turbo will deliver more and more air inside. So generally diesel engines are turbo powered, but petrol engines, they don't have it. It is naturally aspirated. But right now the technology is advanced. We are putting turbo inside petrol also, so that the power will be even more higher. Well, it becomes more costlier. Generally compared to petrol and diesel engines are costlier. But when you put turbo into a petrol engine, it becomes even more costlier. Is it clear? So you can write petrol engine, less maintenance, diesel engine, high maintenance. Generally, petrol engines have lesser maintenance cost and diesel engines have higher maintenance cost. Petrol engines, less maintenance, diesel engines, high maintenance. And also you can write petrol engines are comparatively simple, but diesel engines are complicated. Simple, complicated. Petrol engines are simple, but diesel engines are complicated. Petrol engines are economic, diesel engines are costlier. Have you noted this? Yes. Look at the comparison between a petrol and a diesel engine here. I've taken the Hyundai Tucson as an example. Yeah. Look at this. Left hand side is petrol and right hand side is diesel. If you compare petrol and diesel, look at the power for petrol, 154 brake horsepower. What is the power given for diesel? 184. Definitely the power is more. More than the power, what you have to observe is the RPM given. What is the RPM given for petrol? 6300. You have to floor the pedal, push the engine to 6300 RPM to produce 154 brake horsepower. But that can produce more than that at lesser RPM. Then similar to the torque. I told no, it is expressed in Newton meters or the pulling capacity. What is the torque here? 192. Look at the torque there. It is 416, much more higher. Now this produces 192 at how much RPM? 4,500. That produces at just 2,700. So definitely diesel engines are more powerful. And look at the cost. Petrol starts from 27 and diesel it goes up to 34. Is it clear? Yes. Now we can close the tabular column. You make one more tabular column where we are going to compare these two, internal combustion engines and electric vehicles. Internal combustion engine, COMBUSTION, combustion, internal combustion engine. Okay, you're going to fill the tabular column. I'm not going to tell anything here. You tell ideas one by one. You have a petrol or a diesel vehicle, alongside you have a EV. Make a logical comparison. Yes, pollution. We generally come to pollution. We'll start from the technical terms. First, for internal combustion engine, drive train, TRAIN, drive train hyphen engine. For internal combustion engines, the drive train is engine. Train, 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 drive train. So the series of machines that drive it. Drive train is engine. For this one, drive train is motor. Then, any other comparison? Yes, so that's what this runs on fossil fuels. This depends on fossil fuels. Internal combustion engine depends on fossil fuels. And electric vehicle depends on secondary cells. Technologies that give secondary cells. Okay. Any other comparison? Let's talk about the expense. Which is more costlier? Electric vehicles. We can write initial setup cost is lesser for ICE, internal combustion engine vehicles. Initial setup cost is higher for EVs or electric vehicles. Then we have to talk about something called as running cost. What's mean by running cost? The money you're going to spend for driving per kilometer. That's called as running cost, which will have lesser running cost. Electric vehicles. Higher running cost for internal combustion engine, lesser running cost for EVs. How is that? 1 liter petrol, let's keep it as 100 rupee, for example. 100 rupee you're spending on petrol, and it goes, say, 10 kilometer. So that is, what will be the cost you're incurring? 10 rupee per kilometer. You have to include the mechanical depreciation and everything. Altogether, it will be around 12 to 13 rupee per kilometer. Usually for a normal cab or something, it will be around 12 to 13 rupee. And that's why if you see Ola, Uber, all of them, they charge somewhere at 17 rupee per kilometer. So that the actual profit is 5 to 6 rupee per kilometer. So if you're traveling 10 kilometers, very easily they will get around 500 rupee or 50 to 500 rupee as a profit. Generally varies. Now, if you take electric vehicle, the estimated cost for MG, Comet, or all these small electric vehicles, no, it's around 70 pice per kilometer. Look at the difference. Goes up to 10 or 13 rupee per kilometer. This is like 70 pice per kilometer. It depends on the electricity also, but mean value is less than 1 rupee per kilometer. So definitely the running cost is lesser for electric vehicle, more for internal combustion engine. Okay, anything else? Power, yes. And right, power delivery for internal combustion engine, it is linear. Power delivery is linear. When we say power delivery is linear, over time the car will accelerate, correct? But power delivery for EV is instant. That's why it goes up to 100 kilometers per hour in 2 seconds. Power delivery is linear for internal combustion engine, and power delivery is instant for electric vehicles. Then let's talk about stability. Which is more stable at high speed, internal combustion engine or electric vehicle? Make a random guess. Which will be having higher stability when it is traveling at a fast speed? Okay, I repeat, which has a body stability, better body stability at high speeds. We generally think internal combustion engine, but it's electric vehicle, because you've heard about a concept called a center of mass. Yes, the place where the most of the mass of the body acts, that's called a center of mass. Internal combustion engine, most of the weight, it is in the front portion, correct? And that's why when you apply brake to a vehicle, no, you face something called as a nose dive. The car goes to the front and then it comes to the back. That's called as nose dive. But if you take a electric vehicle, you are sitting on battery packs. So battery packs are laying low and the entire weight of the car is very lower. Even when you go at 70, 80 kilometers per hour, if you're going to cut through the barricade, no, you won't have the body roll. And most of the times the car will not roll over. That's because most of the weight is laying at the bottom. High speed stability is lesser for EV. High speed stability is lesser for internal combustion engine. High speed stability is more for EVs. High speed stability or the body stability. Okay. Anything else? Depends on non-renewable energy. Internal combustion engine always depends on non-renewable energy, but for electric vehicles, there is option for integrating renewable energy. What if the electricity comes from solar, geothermal, wind energy? So ICE always runs on non-renewable energy, but this can be a mix of both, but there is a scope for shifting to renewable energy also for electric vehicles. Internal combustion engines always runs on non-renewable energy. EVs can run on renewable as well as non-renewable. Then internal combustion engines emits toxic gases. Internal combustion engine emits toxic gases. Electric vehicles, nil emission. Okay. And followed by that, next you can write IC, generally noisy operation. Internal combustion engine, noisy operation. EVs, silent operation. Noisy operation, silent operation. Tell me the question. But is it making much noise like a normal bus? When a normal bus is starting, if you stand near them, that's all. You thick black smoke comes. You have seen movies like Sundara Travels and all. What happens? So thick black smoke is emitted and it makes a lot of noise. But here, lesser noise is emitted. We can say it has noise, but comparatively silent operation. That's all. Anything else? Think. Okay. Internal combustion engine, more moving components. Internal combustion engine is more moving components. Electric vehicles have lesser moving components. Since internal combustion engine has more moving components, and right, maintenance cost is high for internal combustion engine, ICE. Maintenance cost is high. And for EVs, the maintenance cost is low. Electric vehicles, the maintenance cost is low. Okay. Anything else? Depreciation. For internal combustion engine, it's high. And for EVs, it's low. Depreciation. It's high for internal combustion engine, but it's low for electric vehicles. How many points? At least 5 to 10 points. 10. Okay, can close the tabular column. Look at the mains question they asked in 2023. Consumption of electric vehicles is rapidly growing worldwide. How do electric vehicles contribute to reducing carbon emission, and what are the key benefits they offer compared to traditional internal combustion engine vehicles? 15-mark question. Given you sufficient points already. You take down the question, try writing answer later. You can copy the question. Noted this? Yes, you can try writing the answers later. With this, we are completing energy technologies. The only things left over includes electronics and ICT, for which I'll need 3 classes, 2 to 3 classes. And followed by that, we have biotechnology. That's all. So maximum 4 classes we'll be able to complete it. If I start electronics ICT now, we have to leave the topic hanging. So we will wind up the class here. Tomorrow, I will update the class timings through your WhatsApp or Telegram channel. Wait for a minute, because today I think the polity faculty canceled the classes since he had some health issue. If he is not returning tomorrow due to health issues, we'll be having a 5-hour session. Otherwise, we'll have 1 session. Clear? Yes. Pooja ma'am, do you have any doubts? Tomorrow before classes, no, I will send you a material also for electronics ICT. Just go through the material, have it handy, because electronics ICT, there are a lot of mains topics. I will send you the concepts. After reading the concepts, then we have to write advantage and disadvantage. So your notes, no, generally it will have the title followed by that small keywords about the technologies, not elaborate notes, because you already have it in your PDF, which I'll be sending. Yeah. So topic, short keynotes, and followed by the advantages and disadvantages. That's how we are going to cover. Clear? Yes. Right. Thank you.